Welcome back to the Muse and Greg. One of the first reviews I published on this channel was of a 1200 watt G&L brand pure sine wave inverter we'd bought for our caravan just before starting 2 years of full-time travel around Australia. That served us pretty well, but we've since sold that van and bought a new one with an air conditioner that draws close to 1500 watts when running. While I considered another G&L unit because we'd had a pretty good run from it, I eventually settled on this 2000 watt iTechWorld pure sine wave inverter with ATS and RCD. Who doesn't love a few good acronyms? I paid just under $1,000 including shipping for it, which included the same 5% discount you can get too by using coupon code MUSING on iTechWorld's online store. Why not save yourself a few bucks and help my channel at the same time? Now, that's quite a bit more expensive, but I spent that extra money because of the first of those acronyms, ATS. Now, I'll talk about what that does in a minute and why it might be important for you, but first let's take a look at the product. The iTechWorld inverter comes in a nice black, orange and white box with a smart matte laminate. It looks a lot classier than the gloss white cardboard they use for their solar blankets, so I hope they change the packaging on that soon. Inside the box you'll find the inverter, two 80cm long heavy DC power cables, an AC input power lead for the automatic transfer switch, and an instruction manual. I was a bit surprised there were no shock absorbing grommets like my G&L inverter had, but it's a small thing. Allowing for the space taken by the power cables on the end, the inverter measures 50cm long, 21cm wide and 12cm high. And with the two heavy DC cables attached, it weighs 6.2 kilos. Now I also bought a remote controller with it at the same time, the RC2 model. This allows you to install the inverter out of the way somewhere and control and monitor it all via this neat little controller which you can install on a panel somewhere. This came in a similarly schmick box which contained the remote, a 5-metre long remote cable and a set of instructions. The remote's got a simple on-off switch and a range of LEDs showing battery voltage, inverter output load and other indicators for various operating conditions. We'll see all that in the testing. For $50 to $80 extra, I think it's definitely worth it if you're looking for a clean installation while still being able to monitor all of the inverter's functions. So let's take a look around the inverter. Firstly, we've got the main power switch over here. You turn that on or off to activate the inverter. This is the AC input, so power from your mains input comes in here to the inverter. This is the power output that goes to all of your plugs, appliances, whatever you're going to power off the inverter. The RCD, that's obviously a really important safety device which this inverter's got. That's where this one's really important. That's the earth connection. Really important that's connected to some chassis part of your caravan. So the kitchen sink or something like that. This is all the sort of stuff that an electrician will be able to sort out for you. That's all of this area. And then you've got over here an RJ11 port for the remote that you can just activate the inverter on and off. And it's got a few little indicators here. You've got the power LED, a fault LED. There's then an LED to indicate you've got mains going in which case the mains will go straight back out to your appliances, which means the bypass LED will be on too. And lastly, you've got a USB port in case you need that for something. The other end of the device is pretty clean. You just got the positive and negative inputs from your battery, and then a couple of temperature controlled, load controlled fans. So these don't run the whole time. They only spin up when and as necessary to keep the device cool. So obviously as the load increases, these fans will increase. A quick look inside shows pretty standard Chinese manufacturing, and I don't mean to say that that's terrible, it's just okay and about what I'd expect to see from China. It's fairly neat and uses mainly surface mount components, which is good, and taller components like the capacitors and the heat sinks have got silicon around the bottom to absorb vibrations and reduce the chance of the solder joints breaking, which is also good. However, the wiring coming from the end panels onto the board isn't secured, and in a vibration-prone environment like a vehicle, this could eventually cause the solder joints at either end to crack. Some of the glue and silicon slapped around just looks a bit daggy, and there are two daughter boards poking up from the motherboard which will wobble back and forth. While they've also got some silicon strain relief to reduce that movement, it would have been better to build a new board for these functions so there's one less point of failure. I don't see anything here that would make me not recommend it, it's just not quite what you'd get on an absolute top end product, where you might even get a layer of silicon over the whole motherboard like Redarc's DC to DC charger, as that provides excellent vibration protection and potentially an IP rating. Now, I won't spend much time here on the inverter's other specifications, you can read those for yourself on their website, but I'll just point out three things which I think are important. Firstly, the surge power. This is a 2000 watt inverter, but it'll deliver 2400 to 3000 watts for 10 seconds or 3000 to 4000 watts for 2 seconds. Now this is really helpful because if you're planning on running anything that's got a high startup current like a compressor fridge or an air conditioner or anything that's got a motor, it's going to draw a lot more than its standard load when it first starts up. Having this extra capacity in the tank means it's probably got the push to get these hungry appliances started before they settle back to their running power. The second point is the warranty. Like iTechWorld solar blankets, this inverter only comes with a 12-month warranty, which at this price point I think it's a bit light on. Units with comparable functions and the same warranty can be found for a lot cheaper, like the $300 Renogy unit, while the high-end EnerDrive equivalent is only a couple of $100 more but comes with a 5-year warranty. I'll say again, I think iTechWorld really needs to increase their warranty to reflect the premium price point they're selling it at. Finally, 2000 watts of power at 12 volts means your batteries will need to be able to deliver about 170 amps, which is quite a lot. So you'll need to make sure they're capable of delivering that sort of current, otherwise you'll need to factor in a battery upgrade too. And while I'm on batteries, I researched this recently and found that while you can find cheap lithium batteries with the same amp hour rating as pricier ones, the cheaper ones do have a lower maximum current rating, lower number of charge-discharge cycles, they're often heavier and they've got a shorter warranty. Now these things may or may not matter to you, but make sure you do your homework carefully and don't just look at the upfront cost of a battery when the time comes. Okay, now what about these acronyms, ATS and RCD? RCD stands for Residual Current Device, and you've probably got a few in your house. It's a safety device which disconnects power if it detects an unsafe condition. So let's say this is your power setup, with active coming into the house on the brown, neutral going back out on the blue, and green for the earth. Under normal conditions, when you connect an appliance to a power point, all the current flows out of the active pin of the power point, through your appliance, and then back on the neutral pin. The RCD measures that to make sure the same amount of current is flowing through both wires. But if a fault occurs where something touches the active wire and some of that current runs to earth, not all of it is going to come back on the neutral wire. There's been some residual current. As soon as the RCD detects that imbalance, it trips and disconnects power to prevent electrocution. It's a handy device to have anywhere, especially on a mobile setup such as a caravan or boat where you could have moisture around. So having it built into the inverter means you're protected when the inverter's running and you don't have to shell out another $100 or so to buy one separately. Now what about ATS? This for me was the main reason I chose the iTechWorld inverter, the automatic transfer switch. So how does an automatic transfer switch work? Let's say this is your caravan or motorhome or boat or some other vehicle. You plug mains power into it, which sometimes also gets called park power or shore power, and it runs things like your fridge, your lights, power points and all other things like that. And when you unplug the power, they all turn off. Let's now cut that main power wire and put our inverter in its place, which has two important connections on it. It's got the AC mains power in and AC mains power out connections. Now there are two parts to this inverter. There's the power generator that uses your batteries to generate the AC power, and there's also the automatic transfer switch. As you can see, this is basically just a simple switch. The common terminal of the switch connects to the AC output of the inverter, which goes off to your appliances, while the switched side can connect to either the AC input or to the inverter's internal power generator. Under normal conditions, the automatic transfer switch simply connects the mains input to the mains output. So when you connect power to your van, the power runs into the inverter and then straight back out to your appliances just like before. It's as though the inverter's not even there. But what happens when you disconnect the mains power? Well, as soon as the automatic transfer switch detects that the mains has been disconnected, it instantly switches across to the inverter's internal power generator, and now your appliances are being fed power from the inverter rather than from that power coming in from outside. And that's all there is to it. As soon as you connect the mains power back in, the automatic transfer switch disconnects from the inverter and jumps straight back to mains power, and your appliances just keep on running as though nothing happened. You can get an electrician to install an automatic transfer switch separately, but the cost including the installation would be a few hundred at least. Given this inverter's got it built in and at the time of filming is only $200 more than the version without the switch, it's a no-brainer to get it built in if you need one. And to be honest, I think if there's any chance you might want to use this function at some point in the future, I would still get the version with the switch, even if you don't need it now. The inverter's still going to work as normal even if you don't use the switch in the short term. When it comes to installation, you really should do this properly. You need a reliable earth for safety, plus a beefy 250 amp input fuse to protect the system in case something goes wrong. Don't try to get away with a blade fuse here, they won't take the current. You can get a suitable MIDI fuse from iTechWorld for about $35, or there's other options available. Now, there are a heap of warnings in the manual around installation, and in all likelihood, an electrician is going to be doing the wiring for you because the ATS and RCD functions require connecting to the mains power and the right earth for your setup, whatever that might be. However, if you do want to do some of the physical installation to make the job a bit cheaper, make sure you look through these parts of the manual first. Note, for example, that if you're going to be running AGM or flooded batteries, they say don't install the inverter in the same compartment as the battery if you're using these types of batteries to prevent issues with flammable or corrosive gases. Okay, that's all that out of the way. let's now head out to the van and see what things we can run off this inverter. We're going to be firstly testing a laptop charger. That draws about 45 watts, so next to nothing. Then we're jumping up to a heat gun, a 1200 watt heat gun. This hairdryer is a variable one. It goes from basically next to nothing up to 1800 watts. This is an 1800 watt toaster, and then we've got a 2000 watt heat gun. This is a pulse width modulated heat gun, which means you can adjust the temperature, and therefore when it's going flat out it'll draw 2000 watts, but when you wind it back it will just pulse the power, so it's not continuous. In addition to that, we're going to be testing the air conditioner, which when it's running draws about 5 amps, about 1200 watts, but I'm not sure what it draws on startup, so that's going to be really interesting to see how well it goes on startup. And also this microwave, which draws 1300 watts. So hopefully between these things it's going to cover most of what people might need to use in a caravan. Plus if we add a couple of these things together, we'll get over 2000 watts. Okay, so here's the setup we're going to be using. We've got 2 batteries here which are wired up in parallel. Done that because these are not lithium batteries, and we need to be able to provide enough current into the inverter to make sure we're able to get the full 2000 watts out of it. And then this multimeter here is going to be measuring the battery voltage that's going straight onto these 2 points here. This meter here is going to be measuring the output of the inverter, so basically the voltage, the 240 volts coming out of here. We're going to be monitoring that to see how accurate that is, how close that stays to 240 volts throughout the testing. This meter here is going to be measuring the power, so the power from all the things we plug into it, to see how much power in total is being drawn. Now we've also got, at the moment, we're always going to have this appliance here, which is our oscilloscope. That's going to allow us to be able to measure the waveform to see how clean a sine wave it is. It's supposed to be a pure sine wave inverter, so we're going to have a look at that waveform to see how clean that waveform looks. So the crow is going to be running off the inverter as well as whatever else we plug into it. So this will give us the total power that's coming out of the inverter. So just before we start the test, what we're just going to do is measure how much current the inverter draws when it's turned on but there's no load attached to it. So I'm actually going to unplug that completely, so there's no load going into the inverter. I've got this multimeter here set up now on measuring current. This is sitting right in here, so this is going to be measuring the current going into the inverter when we turn that on. Okay, let's give that a flick. So it starts off on 0.5 amp. And so it's sitting just below 1 amp. So if you've got the inverter running and nothing's connected to it, it's going to draw around about 1 amp of current from your batteries just to run the internal circuitry in the inverter. Right, so you can now see output voltage from the inverter. It's 235 volts AC. Let's turn the oscilloscope on and we'll have a look at what that waveform looks like. Currently 24 watts is what the oscilloscope is drawing, so we'll just give that a second. Here we go. Oh wow, now that's a nice waveform. Wow, that is really clean actually. I'm pretty impressed with that. That is cleaner than what you actually get from the mains. No crossover distortion at all. I'd be very happy with that powering any of my devices. So the first thing I'm going to be testing is the laptop charger. That's the laptop over here. So let's plug that into a test socket. Yep, so 64 watts, battery voltage 13 volts, still holding 240 volts. As you can see, this is showing the battery is full and there's no load in the inverter, which there's not very much load. Good, that's a nice start. Let's do the heat gun next, 1200 watt heat gun. There we go, we're ready to go now. When we turn this on, we should hear a few things happening. This battery voltage is going to drop down because we're going to be pulling about 100 amps out of these batteries. You'll probably hear the fan start up in here. Things are all going to change quickly, and this should jump up to around about 1250. Let's go. Oh. Okay, that's actually pretty good. I'm pretty pleased with that. Load, we've got about 50% load, 12.3 volts, still holding 230 volts, 1100 watts coming out into the heat gun. That's quite hot. You can see the heat coming out of there, and our waveform is still nice and clean. Excellent. It's doing well so far. Nice job, iTechWorld. Now, next thing we're going to do is this hairdryer. This goes up to 1800 watts, but we're not going to put it on 1800 watts straight away. We've got the middle heat setting. Okay, so it's 600 watts now. 600 watts for drawing. Cut out. And this should go out to 1800 when we pull this in. Okay, load coming up. 12 volts, 220 volts, still holding pretty well. Our waveform's still nice and clean. 1500 watts is coming out of this in total on flat out, and it's holding them well. And now we hear the fan on the Might have just heard the fan and the inverter come in then. Good. Looking good so far. Okay. Our next test is going to be the toaster. An 8100 watt toaster. Look, I dare say it's not going to have any problems doing this, but let's just try it anyway. Let's put the toaster down. Ooh, look at that load's jumped up. 1600 watts. There goes the fan. We're still holding a pretty clean waveform though. No sign of distortion. 220 volts. So the voltage is starting to come down a little bit now. Just going to jump in here. This lower output voltage from the inverter is the reason the power figures are a bit lower than what the appliance says. A lower supply voltage means the appliance draws less current and consumes less power. If you want more information on how we calculate all that out, check out my series on electronics to basics. We'll see this happen more as we load the inverter up even more in the next few tests. That should be 240, it's down to 220, so we're nearly within 10% of its rating. Good, and that fan turns off pretty quickly. That's good. I'm quite pleased with the inverter so far. Okay, now the next test. This is the one I'm actually waiting for. I'm going to do this one next because I'm really looking forward to this test. We're going to test this air conditioner because this is the one that I really want to know how that's going to work for. So we're going to be testing on fan, which doesn't draw very much. Compressor is the one that's really going to suck a heap of power out of this. So let's chuck that in. Okay. Still 12.8 volts, that's pretty good. So put it on to fan. It's just the fan going, and as you can see, only 64 watts. The real question is going to be what happens when we turn it on to turn the compressor on. Okay, let's go. Ready, set, go. Wow. Okay. That's done that. There goes the fan on the inverter. Still got a nice clean waveform. 700, 800 watts. The load's actually dropped down now. Let's turn the fan right up, flat out. 750 watts. Wow. Right, let's now try the next heat gun. Now this is the one that goes up to 2000 watts. Okay, so we're going to start on the fan setting, the basically no power at all setting. Okay. Okay, that's just slightly warm. 233 volts, still looking pretty good. And now let's start to wind this up. Now this is going to be hard work for the inverter because this is a pulse width modulating device, which means it's going to pulse power like this, on and off, on and off. There you go, you can see that now. So you can see the power meter jumping around 470, 714, 427. This is hard work for that inverter because the load's constantly changing, but you see the waveform is still looking nice and clean. Turn that, whoa, now look at this voltage come down. Well, it came down a bit, it's hovering around about 220 volts. Now I'm going to make it a little bit harder for it. Get on a bit. I'm going to go flat out now. Oh, something just beeped. Okay, okay, so 1700 watts now we're drawing out of that. Now it's flat out. And we've still got a clean waveform. 217 volts. The voltage is getting a bit low. That's the only problem I'm concerned about there. Right, and the battery input voltage is getting a bit low as well. Okay, let's turn that off. Give that poor thing a chance to recover. The microwave. So we've got the microwave plugged into this cable, running down to the inverter. Let's give it a shot to see what happens. Okay, now I don't know what happened down there because I was watching the microwave, but it started up. I don't want to run it very long, of course, because there's nothing in there, but it started, it worked. Okay, let's now try the air conditioning on heating. Okay, let's fire up. Let the compressor start up, 1400 watts. Yeah, no, that's getting warm. Wow, okay. Well, that's pretty good. The only thing we haven't done is actually taken this over 2000 watts. So let's see if we can connect a few things together and see what we get. Okay, the way we're going to do this is use the heat gun and the hairdryer together. Now, supposedly, if there's enough battery voltage, this has got the capacity to be able to run a peak of over 2000 watts, so 2400 to 3000 watts for, I think it's about 10 or 20 or 30 seconds. I'll put the information up in a second. Right, heat gun first. 700 watts. Okay, now let's jump up to 2300. Oh, well, not quite, because the battery voltage has come down quite a bit now. I reckon we're going to knock that out if we go up to full power. Whoa, look at that. 2265, 11.8, that's amazing. It's running flatter, it's overloaded, but it can do that for 30 seconds. And there we go, now it's stripped off. Wow, that's pretty impressive that it's made it for that long. Okay, so you see we've got the fault light come on now. Now I'm assuming if it's a fault you just turn it off, like most good reset systems. Turn them off, turn them back on. And there we go, let's just put that on low just to make sure that's still working. Yep, there we go. She's still alive. Everything's coming back. There's our waveform, looking nice and clean. And at full power. Good. If you're liking this video so far, please like and subscribe. Okay, now I'm going to show you how the automatic transfer switch works inside the inverter. So as I described before, what the automatic transfer switch does is means that you can have power running in from, say, the caravan park. If you're connected to a caravan park, you can have the input from the park power coming into the inverter. And you've got the inverter output. And whenever you've got power on this input lead, it will disconnect the inverter and just run the power straight in and straight out. So all your appliances that might be connected to your output of your inverter can all be running directly from the park power. And when that's disconnected, when that comes out, it will then switch back to the inverter. So I'm going to give a demonstration of that now. So we've got this AC input lead, and as you can see, it's connected over to this power point, which is currently turned off. We've got power on the van, so this would be active once we turn that on. As you can see at the moment, the inverter is turned on, and we've got the inverter output light illuminated, and obviously battery is full. Same with 14 volts on the battery. 236 volts is coming out of the inverter, that's what the iTechWorld inverter is running, and 25 watts, which is just what the Crow's using. Okay, so what we're now going to do is to flick on the power over here, which is going to simulate plugging your cable into the side of the caravan, or park power, shore power, whatever you want to call it, and we'll watch what the inverter does. Tick. Okay, so what you see now, the AC in and bypass lights are both on, and we also see this on the control panel here. And that tells us that we're now running off park power, from the caravan park or whatever, and the inverter is bypass, which means the power from outside is running into the inverter and straight out onto here. Interestingly, what we're now seeing on this meter here and the oscilloscope is the waveform that's actually coming from the mains. Okay, this is what your house gets. And as you can see, it's actually not a brilliant waveform. It's nice and smooth, but it's actually got a little bit of clipping on it. So the top and bottom of the waveforms are chopped off, 242 volts, but a little bit of clipping on that waveform. Again, if we turn this off, I'll try to like this. Flick. Look at that, it's done, and we're back onto the inverter. So the iTechWorld inverter actually gives a better waveform than what the power station does. And you can see voltage has dropped down 236. That's the output from the inverter, just very slightly lower than what the output from the mains is. Inverter, mains, inverter, and it's instant, isn't it? You can see how quickly it switches over. Slight delay when the park power is connected when the inverter disconnects. Interestingly, I guess if we turn that off, it still works. So the transfer switch actually stays locked over even when the inverter is turned off. Now obviously if you switch it off, you lose all your power completely. Turn your inverter on, she'll come up. Here we go, 200, come up to power, 240, and then your park power comes on, and we bypass. Okay, I think that's all the testing in here we need to do.
Okay, here's the summary of everything we've seen in the performance testing. Here's the raw data for nerds who like stats. For the rest of us, let's take a look at a graph. In this graph, the blue line represents the output power delivered by the inverter. The purple line shows the voltage of the battery supplying the inverter, and the orange line shows the inverter output voltage. Ideally, this orange line should stay within the yellow rectangle, which covers 240 volts, the top green line, down to 216 volts, the bottom red line, which is 10% below that 240 volt rating, the maximum tolerance allowed. The green line also shows the inverter's 2000 watt rating. So you can see from the blue power line that the inverter was able to deliver 2000 watts over a range of different appliances, as well as a brief overload up to 2250 watts. You can also see that under overload conditions, the orange output voltage line dropped out of the acceptable voltage range down to about 200 volts. However, the inverter itself turned it off after about 10 seconds, so this low voltage condition didn't continue and it wouldn't have damaged anything, even though it's not ideal. You can also see that the orange output voltage line and the purple input voltage line follow each other in the same pattern, which probably means that the drop in the inverter's output voltage is probably a result of the battery voltage dropping. I spoke to iTechWorld and they confirmed this. Now, I would have preferred the inverter to keep the same output voltage regardless of variations in the battery, so long as it's within its expected range, but I was only using lead-acid batteries, which do drop their voltage under load a lot more than lithium does. So it's a good reminder that to get this sort of power reliably, you're really going to want to have lithium batteries. So let's wrap up. There's a lot I liked about the iTechWorld inverter. The most important thing, it performed as expected. It delivered 2000 watt continuous and it delivered its overload for 10 seconds as promised. We went up to about 2250 watts. It's pretty quiet operation. The fans were quiet enough and they turned off quickly when they weren't needed. The remote displays some pretty useful information. The waveform was clean. Physically it's quite light, about 6 kilograms, and it's got fairly low idle current of just under an amp. There's not a lot which I didn't like. The price versus warranty equation doesn't quite make sense to me. A 12-month warranty I think is a bit light on for this price point, and this is exactly what I felt about their 200 watt solar blanket when I reviewed that too. iTechWorld should either lower the price to compete with cheaper units, or keep this current pricing and increase the warranty up to say 3 years. That would allow it to undercut the top end of the market while still providing some value. It also didn't hold the 240 volt output as the load increased. I'm not sure whether that might have just been the battery voltage or not, but I was a bit surprised about that. And lastly, just a small thing, tidy up the insides a little bit. Secure the wiring, that's an easy fix, and it would be nice if they added some shock absorbing grommets to the installation kit. But is it the right inverter for you? Well, the answer is no if you're sure that you're never going to get the inverter fully wired into your van's power outlets, and you're happy to just plug a couple of things directly into the inverter when needed. It's also a no if your van's already got a good automatic transfer switch installed, and you're just replacing an old inverter that's gone bung. In either case, you can save yourself at least a couple of $100 and either get the version without an ATS or take a chance on one of the cheaper units out there. But I think for most people, the answer is going to be a resounding yes. If there's a chance you're going to want to run your van's power outlets from the inverter, it's going to be cheaper and tidier to get an inverter with an ATS included like this one. And if you're planning regular or full-time travel, I can tell you from experience, it's so much easier having all the power points just working automatically without having to remember to flick a big manual switch somewhere or plug extra cables in to get the inverter running. I think the iTech unit is a very good value way to achieve this "it just works" functionality, especially if you look out for sale prices and use my 5% off coupon code, which by the way works for anything you buy from their store, not just the inverter. And because I get a small commission on whatever you spend, it helps me to buy more products for independent, unsponsored reviews like this one. Now there are cheaper units out there, both with and without an ATS, but before you consider one of those, do what I did and take a look at customer opinions of the company on a completely separate review site like Trustpilot or Product Review. Now these sites typically attract unhappy customers, so I wasn't surprised to find fairly poor ratings from the other companies whose brands I was considering, especially around warranty and returns. But iTechWorld sits at 4.7 out of 5 stars, which suggests a very satisfied customer base, plus they're an Australian company who's been around since 2006 with local staff. If you're going to run your whole van from an inverter, it becomes a really critical piece of infrastructure. So if it fails, you're going to want to hope you've bought from a company who's got your back, and iTechWorld does seem to fit that bill. But let me know in the comments what you think of their products and service, particularly if you've used this inverter before. I'd also mention that the iTechWorld gave a cleaner waveform than my old G&L did, which might be important for sensitive appliances. The remote control's much better and has got more useful information on it. And if you're building a whole system and you need other things like chargers, batteries and solar, it's smarter to get everything from one reputable supplier, whether that's iTechWorld or someone else. Because if something goes wrong, you've only got one supplier to talk to who's responsible for the warranty on everything, rather than having a whole mishmash of different products from different companies who blame each other for the problem and nothing gets resolved. So there are solid reasons to spend a bit more on an inverter, but if money's tight and you don't need the transfer switch, there are some cheaper alternatives if you're happy to take a chance on a lesser known brand. So that's the iTechWorld 2000 watt ATS inverter. It's performed extremely well in tests, and from my testing so far, I would recommend this product. It was good enough for me to spend $1,000 of my own money on it with the remote, but they've since been on sale for under $800. So if you watch their sales and use my coupon code, you can get yourself a great deal. So I hope that's been helpful. If it has, please share it on your social media with others, and if you'd like to buy me a coffee to help with the next video, please hit that thanks button below. But that's all for now, so I'll catch you next time.